Hello everyone. Thank you for joining us today. We are Group 11 and we are really excited to present our project titled Ethereum-Based Blockchain Voting System. My name is Devan Patel and throughout this project, I worked primarily as a smart contract developer. That means I handle everything that runs on the blockchain side, the solidity programming, designing, and the election logic, managing state transaction and ensuring that our voting mechanism is secure, tamper-proof, and reliable. Essentially, my responsibility was to build the core engine of our decentralized voting system.
And hello everyone, I am Dharmin Patel. My role in this project focused on front-end development and the web integration. In simple terms, I built what the user interacts with, the entire voting interface, the admin panel, and all the visual components. I also connected our UI to the blockchain using MetaMask, ensuring that every action taken on the website directly triggers a blockchain transaction. So together, our goal was to build a fully functional e-voting system that demonstrate how decentralized technologies can make elections more transparent, secure, and trustworthy.
Overall, the project was a real collaboration between us, combining the blockchain logic and the front-end interaction into the complete end-to-end system. Today, we'll walk you through our idea, the algorithm we implemented, our demo, and how we divided our workload. So, so let me begin by giving you a clear overview of our project and the idea behind it. One of the biggest challenge in the traditional voting system, whether it's a paper-based or the digital, is trust. There have been numerous concerns over the vote tampering, compromised machine, and a general lack of transparency around the counting process. Even in digital systems, everything usually goes through a central server, which becomes a single point of the failure. This means that if someone gain access to that server, or if there's a technical glitch, the entire election could be compromised. Now, we want what we wanted to explore was a fundamentally different approach, a system where trust does not depend on a central authority, but instead is built into the technology itself. And that's where the blockchain comes in. Because a blockchain is decentralized and immutable, it provides the perfect foundation for creating a voting system where every vote is verifiable, transparent, and tamper-proof.
In our system, every vote becomes a blockchain transaction. Once a vote is cast, it's written permanently to the blockchain and can never be changed or deleted. This means even if the administrator of the election cannot secretly modify the result. We also built smart contract controlled phases like created, registration, voting, and ended to ensure that actions only happen during the correct stage. Our front end allows voters to register using Ethereum address, cast a vote using MetaMask, and see real-time election updates. The administrator can add candidates, start the registration phase, start the voting phase, and finally end the election. The transparency and traceability that blockchain provides form the core of our solution. So overall, our idea was to demonstrate how blockchain can solve long-standing problems in election system by providing a platform that is secure by design, transparent by default, and decentralized at its core.
So now let's talk about the algorithms and the blockchain concepts that power our project. The first major concept we rely on is hashing. On Ethereum, every transaction is hashed using the KK 256, which guarantees integrity. What that means is that once a vote is added to the blockchain, it's represented by a unique cryptographic hash, making the vote completely immutable and impossible to alter without the detection. This is the foundation of trust in our system. Next, our smart contracts follows a state machine model, which is basically a structured way of controlling how an election progresses. We define four phases: created, registration, voting, and ended. This phase ensures that event happens in a logical sequence. For example, a voter can't vote unless the election is in the voting phase, and they can't register unless the registration was started. This prevents invalid operations and ensures the election runs smoothly and securely.
On the front end, we interacted with the smart contract functions. This library helps us call contract methods. listen to events, and send the transactions securely through MetaMask. Every time a voter registers or casts a vote, their wallet signs the transactions, ensuring that only the uh, owner of the wallet can perform the action. We also implemented strong access control. The smart contract uses a only admin modifier to ensure that only the election creator can add candidate or manage the phases. This prevents unauthorized users from manipulating the election. Similarly, to prevent double voting, we maintained a mapping inside the contract that records whether addresses has already voted or not. Once the user votes, they cannot vote again. Lastly, events such as vote cast, candidate ad, and phase change allowed the front end to track changes in the real time, making the whole system interactive and user friendly. Together, this algorithm forms the backbone of our secure and decentralized voting system.
So now let's go through the live demo of our system. Let me run. Right now I'm in the front end and I'm going to start a server. So it has been started. So let's open local server. First, uh, we have added some accounts like from the Ganache to the MetaMask. So right now I'm in the admin and I'm logging through by admin. So I'm logging. Let's create one election that is MITS election 2025. Let me like enter 6 election for MITS student for year 2026. 2026. So I'll putting the 120 seconds for the registration and 120 seconds for duration. Let me create the election. So yeah, we can see that election was created on the chain in the last one. So let me open the admin on the new. Let me connect. Like I'm logging through the admin. Let add candidate one named Devan. So right now we are in the created phase and it will be changed. Confirm. So candidate one has been added. Let's add second candidate, Dharmin. So candidate two has been added. Now I'll start the registration as I'm in admin. Confirm. So registration period has been started. Now user can register themselves to vote. So now let me log in through the voter accounts. That's the voter one. Connecting the wallet. Register voter one into the work system. So voter one has been added. Log in through voter two. Now add the third voter. Register the third voter as well. So we now registered 3 voters as of now. Now let me log in through the admin. Connecting the wallet. Now right now we are in the registration phase. And after starting the voting, will be changed to voting phase. Confirm. So you can see that here our current phase is voting. So voting has been started. So the registered voters can now can now vote. Voter one, connecting the wallet, and he's going to vote day one. confirm successfully. Connecting with voters tool account. Also going to vote candidate one. Now let's log in through the third voter. Connecting the wallet. He's going to vote Dharmin. Okay. We'll also try one more thing, like I'm going to vote again from the account two. So let's check. It's so it says to fail to vote because uh, voter two has already voted, so he cannot able to vote again. So now let me log in through the admin and the voting period. So admin. So now the voting period has been ended. You can see the current phase has changed to ended. And after that, if someone tries to register or vote, he cannot able to. I'll show you. Let's let's try to register the new voter, that is four. See, you can, like, he's not able to register because the voting period has been ended. And if the already registered voters try to vote, then also they cannot able to vote. See, fail to vote. And let me log in through admin now, and I'll show you the number of votes. And you can clearly see that uh, they won two vote and the Armin one vote. So they can announce the winner from here as well. Now I'll show you. We added these five accounts from the Ganache. We have taken these private keys and added to their account. So we connect Ganache and the MetaMask. Okay. So now let's. All right. So now I'll explain my contribution to the project in more detail. And I also walk you through some of the crucial code that I brought so we can see how logic function on the blockchain side. So my responsibility was the full blockchain backend, everything related to the smart contracts, phase control, voting security, and development. I started by designing the architecture, which includes two main contracts. That's the election factory, which creates and manages multiple election, and the second one is the election, which handles the entire logic for one specific election. Now let me show the first major part of my work. I'll open my remix. Okay. Hmm, I'll show you one function, that's election. Election create election. Yeah. So this function you will see here called create election is something I wrote to allow the admin to generate a brand new election anytime. It deploys a fresh instance of election. The election contract stores the address and emits an event, so the front end can detect the new elections. This is important because our system supports multiple election, not just one, and we need a factory pattern to manage the scalability. I also added event logging, so every creation is traceable on the blockchain. Now I'll show you the start registration function. Yeah. So next, I design the entire election state machine. As you can see, this function here, start registration, start voting, and the end election, are the responsible for controlling how an election progresses. Only the admin can call them, and thanks to the only admin modifier that I wrote, this prevents unauthorized user from manipulating the result or phases. When each function is called, the smart contracts updates the internal state and emits a phase change event, and which the front end listens to. Next, I'll show you the register voter. Yeah, here is this. Here is another key part of my contribution: the logic registration and the voting logic. This function, the register voter, ensures that only legitimate addresses can participate. And this vote function here, I implemented an important security measure preventing the double voting. And you can see here, right here, this guarantees that even if someone tries to vote twice using the same wallet, the contract will immediately reject the transaction that I show you in our demo. I also validate candidate ID and ensures the votes increment properly on the chain. And which is I show you first change. Yeah, you can see the emit vote cast. These events allow the front end to react instantly to blockchain changes. For example, every time a vote is cast, the vote cast event got emitted, and the UI updates in real time. This events-driven architecture is crucial for making the app interactive and transparent. Once all the functions were tested and fully working, I deployed the contracts on the Ganache blockchain using the MetaMask that this Ganache, and that way I show you the MetaMask here. Then I exported the ABI and deployed the address. I'll show you the ABIs. Yeah, this one. So I just have to, yeah, all these and pass them to my partner so he could integrate them into the front end, like in the config.js. I passed all that in here. All the ABIs are here. You can factory ABI and then another one. So overall, my contribution covered everything from the contract design, security logic, and events and debugging to the final deployment. Now I'll pass to the Dharmin.
So now I will walk you through the part I developed, and I will show uh, code pieces of mine. So my role focused on building the entire user interface and connecting it with the blockchain using web technologies. I handled everything inside the front-end folder, including the admin panel, user voting page, and all JavaScript required to interact with the smart contract. So can you, Devan, please show the app.js and scroll to the connect wallet?
Yeah, I'm here.
Yep. So this function, connect wallet, is where a user first connects with MetaMask wallet to our DN. It retrieves the signer, loads the factory contract instance, and prepares the UI for interaction. Every blockchain action starts here. So now you can please show the load election.
Yeah, it's here. Yeah,
So this function queries the election factory uh, contracts on chain to load all existing elections. It calls election count inside the contract and then fetch each election addresses. I also implemented error handling. So if the chain resets or MetaMask is on the wrong network, the user sees a proper message. Now, can you please scroll to the candidate
yeah,
addition and the
yeah, I'm here.
starting.
Yeah,
This function triggers transactions directly on the blockchain. For example, add candidate takes the candidate's name, sends a transaction through MetaMask, and updates the interface. Similarly, start voting calls the smart contract functions to same name. If the admin is not in the correct phase or leaks permission, it catches and reverts error and displays an alert. Now, can you show the show vote and function that submit vote?
Yep. Good.
This is the core voting function on the front end. When a user selects a candidate and submits the vote, this function signs and sends the transaction, waits for the blockchain confirmation, and then updates the UI instantly. It ensures every vote is recorded directly on the Ethereum network through the smart contract written by my teammate. Uh, and in short, I was responsible for everything users see and they interact with. The design, the interface, the integration, transaction handling, events, and overall smoothness of the user interface. Together, our contribution form a complete decentralized voting system.
So all these are our references that we have used in our project. So we relied on the Remix ID, where we can compile, deploy, and the test the Ethereum smart contracts. Where just I show you that I deployed the smart contract. Then we also use the MetaMask documentations, as well as we refer some of the IEEE documentations. That's one of them is the securing the elections with blockchain, a review of blockchain-based e-voting system, and where we got some of the chaining from that reference as well. Then the next reference is this one. This one, the blockchain-based e-voting system. Then we use Ganache, as I show you that, to deploy the local Ethereum for the testing, and the deployment that I use that private keys and enter into the MetaMask for that. Yeah. Thank you. Thank you for watching.
Thank you, Arvind.